Write a rule for the nth term of the geometric sequence. So a geometric sequence, well, first of all, they told us it's geometric, which means our numbers, to get from one number to the next number, you're going to be multiplying by a common ratio. And what's nice is if you know it's geometric, you know what the rule is going to look like. And the rule is always going to be a sub 1, your first term, times your ratio raised to the n minus 1. So just like in arithmetic sequences, for geometric, there's two things you have to know in order to write the rule. That's going to be our first term and the ratio. So if you know those two things, we just write the rule and call it a day. So our first term, if you're given the sequence, is going to be the first term you're given. So we know that first term of 3. Now to get the common ratio, we can look at this and say, okay, I can see what we're multiplying by every time. But if we're not seeing it very clearly, the math that you can do for this is take your second term, 15, and divide it by the term in front. 15 divided by 3 is 5. Now to test that this keeps working, take the next term, 75, divide it by the term before, which is 15, and we get that 5 again. 375, divide it by 75, and we get 5. So we're getting that common difference, or sorry, common ratio in between each term. So now we know that our value is going to be a 5. So we go over here to write the rule. A sub n equals our first term is 3, ratio is 5, and then raised to the n minus 1 power. Now what you want to be careful of here is following order of operations and seeing, what can we do to simplify this. And sometimes people want to go ahead and multiply those together and say it's 15 to the n minus 1 power. But, keep in mind this is multiplication, and here's an exponent up here. And in order of operations, you would have to do the exponent first before you do the multiplication. And as long as this is n minus 1, then we're not able to evaluate the exponent. So we can't touch the multiplication until we do 5 to whatever power we're looking for. So nice thing about the geometric is that at this point, we actually can't do any simplifying and we are done. So there's our rule for the geometric sequence.